Welcome again to my channel. In the last video, we talked about what API is and what REST is. Let's do a quick recap. API stands for Application Programming Interface. API is the way software programs talk to each other. REST stands for Representational State Transfer and is the most popular form of API used in the industry today. In REST, you define endpoints or URLs for your resource, which offer CRUD functionality using the standard HTTP methods like get, put, post, delete, etc. In this video, we will create a simple REST application with get, post, and delete endpoints. We will use Golang for that, but you can use any other language that you are comfortable with, for example Java or JavaScript. While doing that, we will look at some basic rules that one should follow when designing a REST API. We will create an API to manage blocks. First and foremost, you should define your domain model. There might be many objects in your domain. For example, the objects that we will have in our domain for an API to manage blocks will be blog and comments. Before we continue, let's take a short detour and talk about aggregates, because that is where most API designs go wrong. Aggregate is an object that is on top of its hierarchy and can be managed on its own. Please note that there might be more than one aggregates in your domain model. In our example, we have two objects, blog and comments. Can you take a guess which one is an aggregate? In our case, blog is an aggregate. And the other object, comment, will be managed via its aggregate, the blog. This is simply because a comment cannot exist without a blog in our world. So, always start with designing the REST endpoints for your aggregate. And then you can build your non-aggregate endpoints on top of these existing REST endpoints. We will see an example of that when we start coding. Let's start with a simple Go program in Visual Studio, which will print some text. If I run the program from my terminal, I can see the printed text. But we want a running web server and create some endpoints. So let's go back to Visual Studio and change that. In Visual Studio, we first import the package HTTP and then use the command http.listenandserve at port 8080 to start our server. After saving and running the program, if we point our browser to localhost 8080, we get a 404 page not found because our server is not serving anything right now, but at least it is running. Let's go back to Visual Studio and serve some text. To do that, we will use the Go package G. After that, we create a new router which will handle our routes. Then we will add some middleware, which are not really necessary for our example, but they are very useful, which you will see in a minute. After that, we define our first base route and say that this will be handled by a method called handleMainURL. Then we go ahead and implement this method. In this method, we will simply print some text to the browser, hello and welcome to your new blogs app. And after that, we will connect the new router to our HTTP server. If I go back to my browser now, I can see the text instead of the 404 error message. And if you check out the logs in the terminal, you will see some newly printed logs, which are printed due to the middleware that we talked about before. So now we can create REST endpoints for our blog. To do that, first we define our blog. To keep things simple, our blog consists just of an ID, a title, and some content. And instead of using database, we will use a list to save the blogs and initialize it with some data. Now we can create our first get endpoint, which should deliver a list of all blogs in JSON format. To do that, we create a method setRootesForBlog, and inside that we create our /blogs endpoint, which will be handled by a method getAllBlogs, which we will then implement below. This method will use the render library from G to return all blogs as JSON. Now we can open our browser and go to the URL /blogs. We can see that the server returned our list of blogs as JSON. We can even open the developer tools and then see in the network tabs that the correct header was returned, application JSON. We can also see that the correct HTTP status was returned, 200, which stands for OK. That was the endpoint to fetch all blogs. Next, let's build the endpoint to fetch a particular blog using its ID, and that will be passed in the path parameter of the endpoint, like this. Let's go back to Visual Studio and implement this new endpoint. To do that, first we will extend the setRootesForBlog method by introducing a new endpoint handler. This will be handled by a method getBlog, which will be implemented in a minute down here. This new handler will say that any URL with /blogs and /id will be handled by the method getBlog. After that, let's go down and implement the getBlog method. In this method, first we will fetch the ID from the URL, which will be done using the chi.urlparam helper method. After that, from line number 63 to line number 67, we try to find the item in our list or in the database, if you have your blocks in the database, where the ID matches the item. If we do not find the item from line number 69 to line number 71, we will return an error message with status code 404. And if it is found in line number 74, we will render this object as JSON back to the requester. Let's go back to the browser and test the new endpoint. Here you can see the original endpoint /blogs, which returns a list of all available blogs. Let's change the URL by adding a URL parameter 1. As you can see, now the server returns only the blog with the given endpoint. Let's now change the URL parameter to an ID that doesn't exist. For example, 3. As you can see, you get an error message not found. Let's open the developer tools and check the status message returned by the server. You can see that we got the status message 404 as expected. Now that we have created endpoints to fetch all blogs and a particular blog with a given ID, let's create the endpoint to create a blog. If you remember, this endpoint has to be a post endpoint, and the data that is supposed to be passed from the client to the server has to be in JSON format. Before we implement the new endpoint, let's look at Postman and see how our request will look like. In Postman, we enter our URL here, and on the left side, we can select the HTTP method that we want to call. Because we want to send some JSON data, we will select body, and in that we will select raw in the radio button options. After that, on the right side, we will select the data type JSON. And in the box below here, we can type in our JSON data. If you remember, blog consists of an ID, title, and content. ID is a primary key that is created by the server, so we do not have to provide it here. If I fire this request now, I get an error message. That is simply because that the method has not been implemented yet. Let's go back to Visual Studio and implement the new endpoint. First, we will update the setRootesForBlog method. Here we say that the post call to the /blogs endpoint will be handled by the method createBlog. After that, we go and create the method createBlog below there. In this method, we try to read the blog provided as JSON in the body of the request. If there is any error, we return bad request, that is 400, to the client. We also do some extra validation down here to make sure that the title and content are not empty. Once everything is okay, we add the new blog to the list and then return the newly created blog as JSON back to the client. After we have saved the file and restarted our server, let's go back to Postman and fire that request again. This time it worked. We got the status message 200 and the newly created blog with the ID 3. Let's try to send an empty title and see what happens. If we do that, we can see that we got the status message 400 back. We can also completely remove the body and then send the request, and we again get back the status error message 400. If we point our browser to the /blogs URL now, we can see that the newly created third blog is returned in the list. We can also point our browser to the /blogs/3 endpoint, which should return the newly created blog exclusively. Similarly, you can create the delete endpoint. I will leave the implementation of the delete endpoint as an exercise for you. Before we say bye, let's do a quick recap of what we learned. Start with defining your domain model. Once you have done that, you should identify your aggregate. Following the REST standard, you should provide CRUD functionality on your object using the standard HTTP methods like get, post, and delete. Use the noun of the object in plural form to name your endpoint. Do not use verbs like get blogs, create blog, etc. Let the HTTP method define the action for you. And you should always use JSON to pass data. And make sure that you use correct HTTP response code from your server. In the description, you will find some useful links as well the Git where this code can be found. See you in the next one.